Welcome to the section on corrective measures. In this section, we shall apply several corrections to our already existing model and data set. First, we have data augmentation, we have dropout, we have the class weighting. We can also reduce the network. Also note that apart from data augmentation, you could also as well gather as much data as possible. So depending on the exact problem you're trying to solve, you may want to gather as much data which is very much representative of the real world problem you'll be trying to solve. Also, this list is not exhaustive and you could add more corrections to the already existing model and data set we've built already. Getting back to the code, we shall implement our data augmentation strategy. Firstly, we should take this and define this as image array. So this is our image array right here. Take this off, and then we'll define this as our image map or map array. So that is it. Then we take the X, the append image array. We now have Y, we append the map array. Then the first data augmentation we shall do will be that of adjusting the saturation, and we shall have this as our factor. So this takes in the image array, and then here we have the map array. Note that we have exactly the same map array as what was given to us initially, because when we adjust saturation, the pixel positions don't change. Now our next data augmentation strategy will involve data augmentation in which the position of the output pixels actually change. So there we go, we have this flip up and down. But before running this, let's look exactly what's going on with the flip up and down and why we're gonna use a reverse right here. So here we have our test image, and then we shall flip it. So there we go, we now have this flipped image. But then the problem now is this image has been flipped, but what of its output, which is this? When we look at this output, we have this. Let's go back to the testing. Normally that should be that it was modified. Run that again. Okay, so let's come back to this, run this again. Okay, so this image has been flipped, but this is its output or its initial output. Now what we'll have to do is to also flip this output such that it matches up with this input image right here. And to do that, we shall employ TensorFlow's reverse. So the way this works is, if we want to do a flipping in the up down direction, we have to specify the 0th axis. If we want to do a flipping in the left right direction, we'll have to specify the first axis. So let's run this, and there we go. We see that this matches up with this input now, and that's why we include a reverse at this level right here. At this point, that's why we have this reverse of the map array, and we specify the 0th axis. So once this is good, we just run it, run that, and then we could go ahead with the training. While our model has been trained, we could move to the next corrective measure, which is that of dropout. So right here we should have this dropout. We include a dropout layer. We'll specify a dropout factor of 0.5 right here. We take an X, and that's it. So we just have this dropouts after this outputs, and that's fine. So we're done with including dropout. We now